Welcome to lesson 1.10, normal distributions. Today we're going to be talking about everything related to normal distributions, which is a big topic in AB Stats, and I encourage you to practice this one quite a bit, as it's probably the most challenging content that you've had so far. So grab the companion notes. So let's get started. Today we're diving into one of the most important concepts in statistics, the normal distribution. We'll explore how it works, why it's so useful, and how to apply it in real-world situations. We welcome a special guest today, none other than the Prince of Mathematics himself, Carl Friedrich Gauss. We need a data set, and no, we're not going to use social media data set again. We're going to explore the average daily sleep times of pandas in various zoos around the world. Pandas are known for sleeping a lot, but their sleep behavior, is it normal? Let's find out. Giant pandas sleep in 2 to 4 hour naps between meals and spend most of their time sleeping. They can sleep up to or more than 16 hours a day. Giant pandas sleep in a variety of positions, including on their side, back, or belly, curled up, or sprawled out. Pandas sleep and raise their cubs under trees, stumps, or cliffs. They also make temporary shelters in caves and hollow trees. Long periods of sleep are important for pandas to digest bamboo, their primary food source, which is low in nutrients. Let's start with the basics. A parameter is a numerical summary of a population. In a normal distribution,
You mean Gaussian.
Oh, excuse me, Gauss. I didn't mean to offend you. In AP Statistics, we call your Gaussian distribution the normal distribution. In the normal distribution, we have two key parameters that are the population mean, which we use the symbol mu, and the population standard deviation, which we use a lowercase sigma. A normal distribution is mound-shaped and symmetric. Think of it like the classic bell curve. We'll use our panda sleep data to illustrate this. The average panda in the dataset sleeps 12 hours per day, and the standard deviation is 1.5 hours. Now, let's talk about the empirical rule. This rule states that for a normal distribution, approximately 68% of the data or observations fall within one standard deviation of the mean, 95% fall within 2 standard deviations, and 99.7% fall within 3 standard deviations. So using our panda example, we can calculate intervals. 68% of our pandas sleep between 10.5 and 13.5 hours per day. 95% of pandas sleep between 9 and 15 hours per day. And 99.7% of pandas sleep between 7.5 and 16.5 hours a day. This means if you see a panda sleeping for 5 hours, you'd probably think that's unusual. And if one sleeps for 17 hours, let's just say that's one well-rested panda. A z-score measures how many standard deviations a data value is from the mean. The z-score is a standardized value, which means that it is transformed from the specific mean and standard deviation of the data to one that is standardized for all normal distributions. The formula is simple. The z-value is equal to the data value minus the mean, all divided by the standard deviation. For example, if a panda sleeps for 14 hours, we can calculate its z-score, which is 14 minus 12 divided by 1.5, so about 1.33 as our z-score. This means that the panda sleeps about 1.33 standard deviations above the mean.
14 hours sleeping, 1.33 standard deviations above the mean. That is one dedicated sleeper.
Once we have a z-score, we can use a table for a standardized normal distribution. This is called Table A. It will give us the proportion of values that are at or below our z-value. There's a way to do this on a calculator, and I will link that how-to video above. I encourage you to use Table A until you really understand the meaning behind the values. Then you can switch to the calculator for a quicker method. AP Statistics graders will accept either method for full points. Using our previous example, a panda that sleeps 14 hours had a z-score of 1.33, or was 1.33 standard deviations above the mean sleep time for pandas living in zoos. This means that we know that more than 50% of pandas sleep less than this panda. But we want a more accurate calculation. Since this isn't a whole standard deviation value away from the mean sleep time of pandas, we can't use the 68, 95, 99.7 rule. So we'll have to use Table A instead. This is Table A. The area under the curve is all of the probability for this standardized normal distribution. That means that the sum of all probabilities under this curve is 1, or 100%. Let's use our example to illustrate what this means in practice. We read down this first column to the 10th place of our z-score, and then over to the 100th place. So our panda that sleeps 14 hours has a z-score of 1.33. So we read down to 1.3, and then over to the 100th place of the 3. When we do that, we find a probability of 0.9082, which means that 90.82% of pandas living in zoo sleep as much or less than this panda. Because the area under the curve sums to 100%, all pandas living in zoos' sleep times are represented. We know that 1 minus 0.9082 gives us 0.0918, and so that would be the probability that some panda would sleep more than this panda. Lastly, let's talk about percentiles. For example, if a panda sleeps for 8.25 hours a day, what percentile is that? Well, we can calculate the z-score for 8.25 hours and then use our A table to find out the panda's percentile. So we take 8.25 minus 12, and then we divide that quantity by 1.5, our standard deviation, and we get a z-value of negative 2.5, which means that this panda is 2.5 standard deviations below the mean. This means that our panda, when we look at Table A, a cumulative probability of 0.0062. So this means that our panda is in the 0.62 percentile. Only 0.62%, which is less than 1%, of pandas in zoos sleep less than this panda. So to recap, we've explored the normal distribution through the lens of panda sleep times, from understanding parameters to calculating z-scores, and using the empirical rule. Remember, in statistics, it's all about patterns, and the normal distribution helps us see those patterns. Thanks for watching. Stay curious, keep questioning, and remember, in statistics, it's all about finding the answers in the area beneath the curve.